Hello students, welcome. So in this lecture we will see the classification of materials. So now we have seen that there are materials and they are very important for any application. Now we will classify the materials based on their properties. So the syllabus of this section will be like this. First we will study the classification, followed by the structure property relationship. Then we will study the crystalline and non-crystalline materials. Then some properties to describe the behavior of the material. Then there is X-ray diffraction to study the crystal structure, that is the arrangement of atoms inside a material, followed by inorganic solids, silicate structure, and the last one is defects. The CLOs based on these sections are classify engineering materials based on its structure and draw crystallographic planes and directions. So in engineering material we can classify the material into three broad categories. First is metals and alloys, second is ceramics and glasses, and third is polymers. Alloys is a atomic level mixture of two or more metals. At least one of them should be a metal. And here we can see that the main difference in metals and ceramics or metals and glasses is that glasses are generally amorphous in nature, and this amorphosity comes due to the arrangement of atoms. In that you can see the red particles are arranged here, but they are not periodic, they are irregularly arranged. So we can see this structure we can call as amorphous structure, and generally glasses are amorphous in nature. The example is cotton candy. While the crystalline materials such as metals, in that the atoms are arranged periodically, infinitely in 3 dimensions, and generally these materials are crystalline. For example, table salt. And this periodicity or non-periodicity determines the properties of the materials. For example, metals are generally very highly ductile, while the ceramics or glasses are very brittle in nature. Metals are opaque in nature, while the ceramics and glasses are generally transparent or translucent in nature. And metals have good mechanical strength, while glasses have low mechanical strength, but ceramics have good mechanical strength. Metals are good conductor of heat and electricity. The ceramics are bad conductor of heat and electricity. The third category we have seen is the polymer. Polymers are chains made up of carbon, hydrogen, oxygen, and nitrogen. So they are all inorganic elements. Or polymers are generally inorganic materials. Polymers are generally ductile in nature. They have poor tolerance of heat. It means they are thermally insulating in nature. They are non-corrosive. They are lightweight. They have low mechanical strength, and they are bad conductor of heat and electricity. In metals we can see some examples as copper, nickel, iron, gold, silicon, aluminum, brass. The brass is the alloy of copper and zinc. While ceramics generally are oxides and nitrides. For example, Al2O3, that is alumina, ZrO2 or Zr2O3, that is zirconia. In polymers, there are some thermoplasts or elastomers such as polyethylene, polyvinyl chloride, polypropylene, nylon, rubber, etc. Now, if you have a metal, if you have ceramics and if we have a polymer. All these three are separate groups. But what will happen if you combine any of these two? For example, I have combined metals and polymers. I will get a composite, that is metal reinforced plastics. If I combine metal and ceramic, then also I will get a composite, that is boride reinforced steel. And if I combine ceramics and polymers, then also I will get a composite, that is glass fiber reinforced plastic. So you can learn here one thing, that if you mix two different materials such as metals, ceramics and polymers, we will get a composite. So the definition of composite is a mixture of two different materials. So now we have seen the materials. Now we'll see the properties of those materials. So the property is basically the response of the material to the stimulus. The stimulus, we will see here that, for example, if I take a mechanical property, in mechanical property the load is a stimulus and the response is tensile strength, hardness, ductility and brittleness. So this four we can call as a mechanical properties. In electrical property, the stimulus is electric voltage or field, and the properties are resistivity and electrical conductivity. Thermal properties are thermal conductivity and specific heat. Similarly, the physical properties, general properties are density and porosity. Optical properties are refraction, reflection, absorption and transmission. We can have a subcategories into this. For example, in electrical properties we can have two categories. First is magnetic properties and second is dielectric properties. So now whatever material you choose, that material will have some properties and you should look which one property is of your interest. Now the materials processing is very important. For example, we can see that we have taken a steel. If you process it, we can take the steel into the thin wire. That means we can make the steel as a ductile in nature, and if you process in some different way or other way, we can make a mechanical gear from it, and generally mechanical gear are very hard in nature. So what we have done, we have taken a single material, that is steel. The processing is different in two cases. In first case we can make the material ductile, in second case we can make the material harder. So the difference is only in the structure, or difference is only in the processing. Here the property is ductility and here the property is hardness. We have only changed the processing route. So by changing the processing route, what would have happened in that material to achieve the desired properties? So that changing in the material we can call as a structure. So now in the next lecture we will focus on the structure of materials.